Dear students, today I am going to explain the remaining part of nuclei. Nuclear fission. Splitting of heavy nucleus into two or more lighter nuclei is called nuclear fission. This phenomenon was first discovered by Otto Hahn and Strassmann. When uranium-235 nucleus undergo collision with a slow neutron, uranium-235 nucleus bombarded with slow neutron of energy 0.025 electron volts, a compound nucleus is formed which is unstable it splits into barium and krypton with the emission of three neutrons and 200 MeV of energy. 92 uranium-235 plus 0 N1 gives 92 uranium-236. It is a compound nucleus, unstable, splits into barium and krypton with the emission of 3 neutrons and 200 MeV of energy. Barium 56, krypton 36. This is 141 and 92. 141, 92, 3. 236, 92 సరిపోయింది. Neutrons released along with fission fragments are called prompt neutrons. Of energy nearly 1 MeV. These are not useful in fission reactions because of its high energy. Neutrons released after some time are called delayed neutrons. These are useful in further fissions because of their less energy. Energy is nearly 0.025 electron volts. chain reaction. It is a self-propagating reaction in which number of neutrons released increases in geometric progression. It is a self-propagating reaction in which number of neutrons released in geometric progression, that is 3 power 0, 3 power 1, 3 square, 3 cube swan equal to something power 0 equal to 1, 3, 9, 27 and so on. Average number of neutrons released in each fission is 2.54. This is uranium-235 nucleus collides with a slow neutron of energy 0.025 electron volts. 3 neutrons are along with barium and krypton. Barium, krypton. These 3 neutrons again collide with another 3 uranium-235 nuclei. Again splits into barium and krypton with the emission of 3 neutrons. So 0 N1, 0 N1, 0 N1. So number of neutrons released in geometric progression 1 is to next 1, 2, 3. 0 N1, 0 N1, 0 N1. 3 is to 9 is to 27 is to swan. The rate of reaction depends on neutron multiplication factor K. K equal to number of neutrons in present generation by number of neutrons in previous generation. If K is less than 1, number of neutrons in each generation decreases the reaction is in subcritical or under critical state. Reaction cannot be continued. If K equal to 1, reaction is in critical state. Reaction is continued at constant rate. Constant rate. It is under controlled process, means this is controlled chain reaction. If K is greater than 1, supercritical state, the reaction is in accelerating state. K less than 1 subcritical state or under critical state, reaction cannot be continued. K equal to 1, the number of neutrons in present generation is same as that of previous generation. The reaction is in critical state and reaction can be continued at constant rate. If K greater than 1, supercritical state, the reaction is in accelerating state, means in each generation number of neutrons released or produced increases at the accelerating state. This is uncontrolled chain reaction. Atom bomb is based on uncontrolled chain reaction. Above two states, critical and under critical states, are in controlled conditions. Nuclear reactor is based on controlled chain reaction. Controlled chain reaction. Nuclear reactor. It is a device in which fission takes place under controlled chain reaction. Important parts of reactor. First one is fuel. Fissionable material used in the reactor is called fuel. 92 uranium-235 and 94 plutonium-239. Fissionable material used in the reactor is called fuel. 92 uranium-235 and 94 plutonium-239. Moderator. Moderators are used to slow down the fast neutrons. Used to slow down the fast neutrons. Water, heavy water, graphite, etc. are moderators. Heavy water is the best moderator. Control rods. These are used to Control the chain reaction. Control the chain reaction by absorbing some neutrons. By absorbing some neutrons. Cadmium, steel, boron are the control rods. The substances having absorbing capacity of neutrons are used as control rods. Cooling, coolant, is used to remove the heat generated in the reactor. Example, water, liquid sodium, liquid carbon dioxide, etc. Protective shielding. The coolant is used to remove the heat generated in the reactor. అందుకే ఇక్కడ వాటర్ అనేది కూలెంట్ సఫిషియెంట్గా దొరకేది కాబట్టి ఈ రియాక్టర్స్ని సముద్రాలకు ఒడ్డున అట్లాంటి చోట్ల కడతారన్నమాట. అంటే వాటర్ మనకు సఫిషియెంట్ వాటర్ ఉండటం కోసం. ఈ లిక్విడ్ సోడియము, లిక్విడ్ కార్బన్ డైఆక్సైడ్లు కొంచెం కాస్ట్లీ కాబట్టి వాటర్ అవైలబిలిటీ ఉండే దగ్గర ఈ రియాక్టర్స్ని కన్స్ట్రక్ట్ చేస్తారు. ప్రొటెక్టివ్ షీల్డింగ్. Cement concrete walls of 10 meter thick are used as shielding. These are used to protect the surroundings from radiation hazards. Reactors are of two types. One is breeder reactor and other one is power plant. In breeder reactor, the reactor in which fuel which produces more fuel than it consumes. In this non-fissionable material is converted into fissionable material. 92 uranium 238 is non-fissionable material 92 uranium-239. It emits a beta particle -1 beta 0. 93 protactinium neptunium 239 again emits a beta ray -B1 beta 0. Plutonium 94 239. Here 92 uranium 238 non-fissionable material. Here plutonium 239 is fissionable material. Here a non-fissionable material is converted into fissionable material. And second one is power reactor. The reactor in which heat generated is used to produce electricity is called power reactor. Heat generated in the reactor is used to produce electricity. వాటిని స్టీమ్ టర్బైన్స్ నుంచి పంపిస్తూ దాంతో ఎలక్ట్రిసిటీని ప్రొడ్యూస్ చేస్తారు. కాబట్టి వీటిని పవర్ రియాక్టర్స్ అంటారు. పవర్ ఆఫ్ రియాక్టర్ P = NE/T, where N number of fissions, E energy released in each fission equal to 200 MeV. This equal to N into 200 MeV/T. Number of fissions required to operate a reactor of 1 power 1 watt in 1 second is N equal to P into T by energy. P 1 watt 1 second by energy 200 MeV. 200 into 1.6 into 10 power -13 equal to 1 by 1.6 into 10 power -11 equal to 10 into 10 power 10 by 1.6 equal to 6 point into 2 ఉంది కదా, సారీ 2 into 3 3.2 equal to 3.125 into 10 power 10 fissions అవుతుంది. 2 power 1 kilowatt per second N equal to 3.125 into 10 power 13. Power 1 megawatt per second N equal to 3.125 into 10 power 16. Next, number of fissions in 1 gram of uranium 235 is 235 gram of uranium consists of Avogadro number of atoms or fissions. 1 gram of uranium equal to N equal to capital N Avogadro number 6.025 into 10 power 23 by 235 equal to 2.56 into 10 power 21 అవుతుంది. ఇది నంబర్ ఆఫ్ ఫిజన్స్ ఇన్ 1 గ్రామ్ ఆఫ్ యురేనియం 235. ఎనర్జీ రిలీజ్డ్ డ్యూ టు fission of 1 gram of uranium 235 is energy equal to 2.56 into 10 power 21 into 200 MeV. 200 into 1.6 into 10 power minus 13. This equal to 8.2 into 10 power 10 joule. Mass of uranium 235 required to operate a reactor of power 1 megawatt per day M equal to 1 megawatt 10 power 6 into 86,400 by 8.2 into 10 power 10, nearly equal to 1 gram. So, for 1 megawatt reactor per day, energy required is equal to mass of uranium 235 required equal to 1 gram. అంటే 1 గ్రామ్ యురేనియం 235 తోటి 1 మెగావాట్ రియాక్టర్ని ఒక రోజు వరకు చేపించవచ్చు. అంటే 86,400 మెగావాట్స్ ఎనర్జీ అనేది క్రియేట్ అవుతుంది. న్యూక్లియర్ ఫ్యూజన్. When 2 or more lighter nuclei combine to form a heavy nucleus. Here 4 protons fused together to form helium nucleus with the emission of 2 positrons and 26.7 MeV of energy. These reactions means 4 protons fuse అవటం అంటే లైక్ చార్జెస్ కాబట్టి చాలా ఎక్కువ ఎనర్జీ కావాలి రిపల్షన్ని ఓవర్కమ్ చేయటానికి. కాబట్టి అంత ఎక్కువ ఎనర్జీ అనేది మనకు దొరకటం కష్టము. కాబట్టి సన్ను స్టార్స్లో అంత టెంపరేచర్ అనేది ఉంటుంది. కాబట్టి ఈ రియాక్షన్స్ జనరల్గా సన్ స్టార్స్లో జరుగుతుంటాయి. దీస్ రియాక్షన్స్ టేకింగ్ ప్లేస్ at very high temperatures. Of the order of 10⁻⁷ Kelvin. Hence these reactions are called thermonuclear reactions. Thermonuclear reactions. Two sets of thermonuclear reactions are responsible for sources of solar or stellar energy. One is carbon nitrogen cycle. In this, carbon acts as a catalyst. In this, carbon acts as a catalyst. Here 6C12 plus 1H1 gives 7N13 plus energy. 7N13 decays to 6C13 plus positron. 6C13 plus 1H1 gives 7N14 plus energy. 7N14 plus 1H1 gives 8O15 plus energy. This 8O15 decays to 7N15 plus 1 positron. 7N15 plus 1H1 gives 6C12 plus 2He4 plus energy. On adding all these, here 6C12, 6C12, 7N13 all are cancelled. So here 4 protons fused together to form helium nucleus, 2 positrons and 25.7 MeV of energy. The next one is proton-proton cycle. In this also 4 protons fused together to form helium nucleus by the emission of energy. 4 protons, 1H1 plus 1H1 gives 1H2 plus 1 positron. 1H2 plus 1H1 gives 2He3 plus energy. 2He3 gives 2He4 plus 2 protons plus 2 positrons plus energy 26.7 MeV of energy. In nuclear fusion, 0.7% of mass of reactants converted into energy. But in nuclear fission, only 0.1% of mass of reactants is converted into energy. So, energy released in fusion equal to 7 times energy in fission. Elementary particles. Fundamental particles are called elementary particles. Electron, proton, neutron, etc. are elementary particles. Antiparticle. Each particle is having its antiparticle. Antiparticle is of same mass but opposite charge and magnetic moment. Each particle is having its own antiparticle. Antiparticle is having same mass and opposite charge and magnetic moment. ఎలక్ట్రాన్ ఎగ్జాంపుల్ వచ్చేసి ఎలక్ట్రాన్ యాంటీపార్టికల్ అంటే పాజిట్రాన్, ప్రోటాన్ అంటే యాంటీ ప్రోటాన్, యాంటీ న్యూట్రాన్. అంటే న్యూట్రాన్కు ఛార్జ్ లేదు కాబట్టి యాంటీ న్యూట్రాన్ కాదు. అంటే మెసాన్స్ ఇంకా డిఫరెంట్ పార్టికల్స్కి తీసుకోవచ్చు. న్యూట్రినో, యాంటీ న్యూట్రినో. ఎట్సెట్రా. Annihilation. A particle and its antiparticle combined together produce energy due to annihilation of matter. This is converse process of pair production. Pair production లో ఎనర్జీ మాస్గా కన్వర్ట్ అవుతుంది, అనిహిలేషన్లో మ్యాటర్ ఎనర్జీగా కన్వర్ట్ అవుతుంది. +1 బీటా 0 ఇవి రెండు పార్టికల్ యాంటీ పార్టికల్ అట్రాక్షన్ మూవ్ టుగెదర్ produce 1 photon of energy 0.51 MeV, another photon of energy 0.51 MeV. +1 beta 0 plus -1 beta 0 gives 2 H nu positroniums. Each of energy 0.51 move in opposite directions. This is about annihilation and pair production. Here energy in pair production, energy is converted into mass, and in annihilation mass is converted into energy. Artificial transmutation of elements. The process of converting one stable nucleus into other by bombarding with alpha particles etc. is called artificial transmutation of elements. 7n example: when nitrogen nucleus is bombarded with alpha particle, unstable fluorine is formed. 9F18, which is unstable radioisotope, it's converted into stable oxygen by the emission of 1 proton. This is discovery of proton. And another example is when beryllium nucleus is bombarded with alpha particle, unstable carbon is formed, which is isotope of carbon. It's converted into stable carbon with the emission of 1 neutron. This is about discovery of neutron, artificial transmutation of elements anamata. This is about nuclei. ఈ లెసన్ నుంచి 8 is around 2, ఒకటి థియరీ బిట్, ఒకటి ప్రాబ్లం వచ్చేటువంటి పాసిబిలిటీ ఉంది. మా ఛానల్ ఎవరైనా సబ్స్క్రైబ్ చేయకుంటే చేసుకోండి, ఫ్రెండ్స్కి షేర్ చేయండి, లైక్ చేయండి. థ్యాంక్ యూ.